What's up, everyone? This is LeetCode 57, insert intervals. This problem's a little bit tricky to wrap your head around the first time, so might make this a little bit of a longer video, we'll see. So we're given an array of non-overlapping intervals where, right, we have a start and an end point for each interval, and basically they're already sorted for us, right, in ascending order by the start point. And we're also given an interval, new interval, with also a start and end point that represents a start and an end of another interval. Insert new interval in an interval such that intervals is sorted in ascending order by start. Intervals still does not have any overlapping intervals. Merge overlapping intervals if necessary. Return intervals after the insertion. Note that you do not need to modify intervals in place. You can make a new array and return it. Okay? So basically, if I know these problem statements are wordy sometimes, but we're basically given a list of intervals, and we're given a new interval, and we basically need to put interval into intervals. Either if they merge, right, we have to, or sorry, if there's overlap, we have to do a merge. Otherwise, we can just insert it. For example, let's say new intervals was like, starts at 100 and ends at 300, right? It would obviously come after or at the end here, so we wouldn't have to actually do any merging. We just add it to the end. Okay. So I have a diagram just so you kind of understand what this problem is asking, right? So this I don't know what color you would call this, like this pinkish red color. That is the actual intervals that were given as inputs, right? Right, the 1, 3 and the 6, 9, right? And then we're given new interval, right? So this is our input. This is also our input for the new intervals. And you see how there's an overlap here? Then we have to merge them, and this is what our final result would be. That makes sense, right? And again, here's the output, 1, 5, 6, 9, right? So you see how there's some overlapping here, so we have to do a merge, and this is what we get. And of course, there's no overlap over here, so this would remain the same. We're going to look at example 2 here. Now, looking at these intervals is kind of annoying, like try to picture it in your head, which is why I drew this out, okay? So here's our original intervals. Here's our new interval, and as you can see, there's an overlap here, right? An overlap here, an overlap here, and this is what our final merge interval would look like. Now, in terms of how you do the merging, you basically take the minimum of the two starts and the maximum of the two ends, and right, that's what you get. Minimum 1, 2, right? 3, 5. The maximum here is 5. This is like the simplified version. Obviously, there could be like another interval here. Sorry. Let me do this color. It could be an interval like here, something like this. In that case, what you would do is you would take the minimum here, okay, 1, 2, so we would get 1, 5, right? And we take the maximum, and then go to the next step, right? And we would find the minimum by comparing whatever this would be against this, and take the maximum of this and this. Basically, when we do a merge for a particular overlap, we're gonna update new interval with the new minimum and the new maximum, right? So then when we have if we have another overlap with the same new interval, we could basically do the minimum checking and the maximum checking again, okay? So this is actually technically continuously updated, because you could have cases where there's more than one overlap, right? And that's how that is handled, okay? So in essence, there's a few ways how we're going to handle this programmatically. I know this video is a little bit long already, but I just have to show you visually so you understand what we're doing. Otherwise, it's kind of hard to wrap your head around this problem, because like you're just looking at a bunch of numbers, right? You have to actually visualize it to make this problem easier to understand. So we could have a case where we have some interval, right? And then the new interval could be after that interval, right? So how do we handle this? Well, this end here for the input interval is less than the new interval start, right? So how would we handle a case like this? Well, we would just append this to our list, or our output array, and then we just move on, right? Now, we don't actually want to append this, because we could have another overlap, something like this, right? So if this interval is before this, we know there's no overlap, right? Based on this endpoint here is less than this start point. If that's the case, we just append this to our array and move on, okay? Now, let's say we have something like this, right? Our input interval is after our new interval, right? Well, in that case, when we reach this and we see, okay, this start here is greater than this here, then we just want to append this to our array, right? Because there's no overlap. And then basically append everything from here afterwards. And the reason we append from here afterwards is because we know there will be no overlap anywhere else, right? So if we have more intervals, oops. If we have more intervals, I have to do the drawing tool. Draw, okay. So if we have more intervals here, then it doesn't really matter, right? Because there will never be any overlap. Because we're only given one. For our new interval, there's always a start and an end, and there's only one. It's not like a list of lists, like this, right? So basically, if this start point is at any point greater than the end of the new interval, then just basically append this to our array and append everything from this point forward, okay? Let me think of some other edge cases. And that's really the problem with this, or that's the tricky part about this problem, is that there's a few edge cases, right? We could also have something where, I don't know, we could have something like this, right? We only have one interval for our input, and our new interval is also overlapping, right? Well, in this case, we would just merge this, right? That's a terrible diagram. So we would just merge this and then put this merged interval into the array. And really, I think like it's hard to explaining this also because we're going to program these like we're going to program our solution a specific way in order to handle a lot of these edge cases, okay? So for example, right, this is one edge case also, which is if not intervals, return new interval. Now, why do we do that? Because intervals.length technically could be 0, so we could have nothing here. But we always have something here, right? Because interval.length will always have 2 points, right? Or sorry, all these intervals will always have 2 points in them, right? A length of 2. But this interval here could technically be empty. What this here is telling you is that there's always a start and an end point. What this here is telling you, though, is that you could have a 0 for the length of this array. So you technically could have an empty array here. But a new interval will always exist as far as... does it look like it always exists? Well, it tells you the length is 2. But it doesn't tell you... Oh, right, sorry. This says 2, and this is intervals I.length equals 2 because you have a list inside a list, whereas here you're only given coordinates. You don't have a list of a list. You just have 2 points, right? So new intervals will always exist, but this might not always exist, right? You could have an empty array. So because of that, we have to do this, right? If we don't have intervals, just return the new interval because we'll always have new interval. Okay? I hope that makes sense based on looking at these constraints here. I hope you can understand the difference between here and here, right? This is saying we have a length of 2 inside of each list, right? All these are of length 2, but it's saying the entire list here could be of length 0 at minimum, right? Here we don't have a bunch of different set of coordinates or points. We only have one, right? So it'll always be 2, meaning this will always not be empty, whereas this could potentially be empty, if that makes sense, okay? I know I'm over explaining stuff, but Again, this problem is a little bit hard to wrap your head around. At least it was for me the first time I did it. So I just want to make sure you understand what we're talking about here. Now instead of doing 0 and 1, right? Like, let's say we're at a specific interval, right? The starting point would be 0. The ending point for that specific interval would be 1. Rather than doing that, I'm just going to define start and end so we can use the variable start and end, right? Where start is equal to 0 and end is equal to 1. Okay? We're going to make an empty list, and let's iterate through these points. Intervals. Now here, let's say new interval is to the right of the current interval, right? That would be a case where we would basically have this. Whoops. I'll go back to, so this is a case where new interval is to the right of the interval. Let's say we're at this interval specifically here, right? This new interval here is to the right of this, right? There's no overlap. So what do we do in that case when we compare this and this? We just add this to our array, right? And as you can see, right? Because there's no overlap. Okay, that's what we're doing here. So in that case, we just do res.append intervals in. Okay. Now let's handle another case. Let's say new interval is to the left of the current interval. Okay. We'll say else if. Right, this would be a case like this would be a case like this, right? Right. So when we're here, right, we're basically taking this, we're appending this to our final array or to our output array, and then we're returning everything from here on forward. Okay. Now here we only have 6, 9, right? But like, let's say we had like, I don't know, like 11, 20 or whatever. That's why we basically add this to our output, and we add everything from here on forward. So we would add this 6, 9 and also the 11, 20. 11, 20 doesn't exist, but it's just a point of basically we're adding everything from here onwards because we'll never have any overlap, right? So if we have a bunch of different points left, we just add all of those to our output array. Okay. So the way we're going to do that, we're going to do res append interval, and then we return res plus, and then from here onwards, right, which would be intervals of I colon, right? So we would basically take it from the current index that we're on onwards, we would append everything. We would append res first, right, which would be basically the reason we do res, not new interval, is because technically we could have other points here as well, right? And we want to include these as well, right? Not just this new merged interval. So that's why we do res plus everything from here onwards. So we include all of this, and basically from here include all of this afterwards. Okay. Again, I know I'm over explaining stuff, but I just want to make sure you understand what we're doing. And here is where there's an overlap. Okay. Now, if there's an overlap, what we're going to do is we're going to say new interval start, and we're going to take the minimum between the current interval we're at and the start and the new interval start. We're going to set the new interval end by basically taking the maximum of the current interval we're at and the end, and the new interval end. I'll go back just so you know what we're doing. So let's say we're comparing these two, right? We compare this point to this point, and we take the minimum, which would be 1, right? 1 is less than 2. Then we compare this point to this point, 3 and 5. We take this point because 5 is greater than 3. Because again, we're doing minimum and maximum, right? And so you can see when we're comparing these and we merge them, we should get 1, 5, right? Using that this way to check, okay? How they actually look like when they're merged. Okay. Now we're not appending here, right? We're actually appending at the end here. Now I'm gonna explain why we do this. Let's say we have this here is perfect, right? Let's say we're only given 1 point as our input for our intervals, and it overlaps, right? So our new interval would look like this. We don't append it though yet, right? We would append it if we had, let's say, another point here, right? Because this point here is greater than this point here, so we would basically append this to our output array, and from here onwards, right? Basically what we do up here. But if we only have 2 points, right, like this, we would set the new minimum and the new maximum, and we would have this. Well, we never actually append that anywhere, right? So we actually have to append it down here. Okay. Otherwise, we would just return an empty list if we don't do this, right? Because we're not appending here. Okay. And the reason we don't want to append here, right? Just to be clear, the reason why we don't want to append here is because we're setting the new minimum and the new maximum, right? Here's a new minimum, here's a new maximum, right? Why would we want to append this to our output array? We don't. We absolutely don't want to do that. Because let's say we have another interval here. Well, now what do we do? Right? What do we do now? Because we already appended this to our output array. Well, that's not good, because technically our merged interval should look something like this, right? And now we want to append. So you don't want to append prematurely. That's why you don't append anything here, okay? So yeah, I hoped this was a good explanation. I tried to explain the various edge cases and how we handle them. I think the problem with, if you're new to this problem, the problem with trying to grasp it is that there's a lot of edge cases you have to consider. The way I like to basically think about this problem is handling like 3 separate cases, right? You could have a case where you have an interval here, and the new interval is to the right of that. Or you could have an interval here, and the new interval is to the left of that, right? Or you could have some overlap somewhere, either like this, or like this, or like this and this, right? But basically I want to think of this, I want to break this problem down and like compartmentalize this problem in 3 ways, right? I could have the interval to the left of the new interval, I could have it to the right of the new interval, or I could have some overlap. And when I have overlap, I have to actually do the merging, okay? And then at the end, of course, we have to append because that means we don't have an interval that is basically to the right. Because otherwise we would do the appending in here, right? But we don't, so we have to append here and we return the result. Okay. I know this is a long video, but like I said, I want to over-explain it because when I was learning this problem, I felt like a lot of videos just quickly glanced over the edge cases, and I did not find it that helpful. So anyways, I hope this helped, and I'll see you in the next one.